That's his article. And I think they allow you to read it for free. And I'll give you the link, or you can get it there. And I will summarize it very briefly. Well, essentially what he is saying is that ChatGPT is brainless. It is not understanding what you are saying. Now, we know it's useful. We know there are lots of, well, just a minute ago, my wife sent me about how much investment is in there and why it is useful for some things. Okay, she did. And we really need to open that. Here. Yes, Silicon Valley is all in frenzy. That article is from Vox. I'll give that to you, but I will say he just goes over the well-known things. It isn't another crypto craze, but it is. So that is exactly what he is proving here. That's not an interesting article, but I'll give it to you just because it is important. Okay, since some people maybe are new here, let's go a little bit. First of all, our structure is like this. We have the file called webinar run, and here you can see what we talked about before. You'll see that every individual time that we meet, by now we changed a little bit. We started from doing the labs from Hugging Face, and Hugging Face is a company for the developers. Very popular company with an interesting history of trying to do a chat application for teenagers, but then open sourcing their library that is now used by all developers. 2,000 companies are using the library, $2 billion is the valuation, and the Hugging Face is not going away anywhere just because it is a programmer tool. However, then there appeared OpenAI, and OpenAI is an investment of many, many companies, Microsoft being the biggest. And they are oriented towards the humanity, towards the public. And that's how we'll start talking. We'll say that's a product for the public. And its valuation is $40 billion. So it definitely achieving its purpose of marketing. But some people may say that it is definitely just all marketing. Yes, it is. Okay, you need the link. And today, my result will be that in a way, it is all marketing. But so what? There's nothing wrong with being marketing. And if it achieves that purpose, which our world is built on marketing, then fine. So just for everybody's attention, that is everybody's information. That is the link that we are using. That's our run. And you guys, you appear right here. Guys and girls, you appear right here. And I see that somebody links and clicks on that link. So what I'm going to do today is, first of all, briefly review Noam Chomsky's opinion, and then go and analyze ChatGPT inside. That will be very useful because that will give us a, first of all, very important understanding why it works, why it doesn't. And secondly, what else can you do? So I think that's key. And let us start. First of all, the opinion of Noam Chomsky, who says that, you see, the biggest problem is that he doesn't understand really. It may be very good about generating something and generating it fast and talking about the right thing, but it never really understands it, not even deeply, but even on a reasonable surface level. So our conclusion today, which I'm giving you away right away, will be that yes, indeed, it doesn't understand, and that's the professional opinion of that, there is nothing wrong. Because, and that's the last opinion that I quote today, one guy said, will AI rise to the level of humans? And he answers no, but instead humans will go down to the levels of AI. I think that's a wonderful thing. It's from a mathematician. It is in Russian, so I'm not giving you that to you. But that is an amazing conclusion, that it's okay that it will stay on that level, because, well, essentially that's what people are. And we'll see the reason. Okay, with all these prefaces, now let's go and analyze something in depth. And that in depth is found in the slides. Okay, now for you, these slides I found in the run. So if you click on this run here, that's the webinar run, then at the very top of that, you see the folder where I put all the needed things. So if you open that folder, then that is where you see the slides. So once we talked about fine-tuning OpenAI, and now we're going to talk about ChatGPT. How does it really work? So I think that will be the bulk of what we'll look at today. And then, well, speak up anytime, but we will also have about 10, 15 minutes to talk about that. I think everybody's intrigued enough by now. So that is the place for the slides. Let's double click on that and play from the start. So the question is here, how does GPT really work? But let's us set it up so everybody knows about it. Everybody is talking about this, and it seems like a gold rush. Set up your own application on top of ChatGPT and make millions and sell the company. So that's why everybody is talking about this. Not as interesting maybe as Visual Basic, even in its heyday and the Hugging Face, but we need to know how to dig for gold. That's why we're here. Who are we using? Marco Ramponi is a brilliant guy. He is a developer and educated Assembly AI. Now, what is Assembly AI? You may ask what that is. That's one of the best AI companies out there. They beat Amazon, Google, and Microsoft for the quality of their transcriptions. Now, in my case, and maybe I showed you that already, we are using them, and that's why I admire them and know them. So that is an application that we wrote for the lawyers, for the public defenders. That is whom the Constitution provides to every criminal out in the street. He has the right to be represented by a lawyer, and obviously there is not much money, at least not often much money. It may be some homeless guy or girl, and so they therefore work in the government provide the system, and when they go on their own, they don't have anything. That's what we wrote. We wrote the software for them that is doing something, and that's where the lawyers organize their work. But they need nice things, and they can upload their files right here. Yeah, you see, they uploaded their files. They can also import the files, and that's where things become interesting. Because if that file is video, then we want a transcription. Now, I think I don't have any transcription, so I'm going to another case. 1, 2, 3. Obviously, I'm a programmer and a tester, but here are all the files, and you can look at that video, and that's one of our guys talking to his son, and the OpenAI No, not the OpenAI. The assembly app provides the transcription. So that's where AI comes in. And what we're looking at today is the opinion of a lead scientist from there. That's who they are and what the ChatGPT is. So of course, GPT stands for Generative Pre-trained Transformers. Let's talk about what these letters mean. The generative means that it generates the next word. It can actually work in two ways. It can either generate the next word based on the previous words, or it can insert the word. So for example, the cat jumped out of the, and you have to insert, and the natural box is a natural word, or the jumped out of the box, and maybe the dog, the cat. That's all it does, even though there is a lot of technical details. So that's what GPT stands for. It generates. Then it is pre-trained. Well, many models are pre-trained. That one specifically is very well pre-trained. We'll be talking about this. And finally, transformer. It's the latest and greatest in neural networks. So I always do it, but that's okay. This is a neural network. That's the very first picture of the neural network with 4 neurons and with a way to train this neural network like this, so that you know the difference between blue and orange. That is a neural network. But then after this, a lot of things happen because this neural network has only 4 neurons and you want millions and billions neurons. That's doable. But if you have all these billions of neurons, then the problem becomes that there are too many especially through those connections. That is simply the coefficients that you need to use. But if every neuron is connected to every other neuron, then billion times billion is too much, even for maybe, well, even for quantum computers. We'll maybe talk about what quantum computers at the very end. So instead, they invented new architectures where they used filters. And then finally, they came up with the idea of transformers. So what is a transformer? That's a new type of neural network that is based on very clever tricks. On the one hand, it remembers what it saw before, because analyzing the text, analyzing the speech, you can only do it by remembering what happened before. But on the other hand, it cannot remember too much, because then computational task becomes again too much. So it limits itself in how much it remembers. And in fact, it remembers not everything, but a summary, a gist, which is called the head, the attention head. Okay, that's enough about transformers. And we'll go here, GPT. So that's what they use. But then they created the new model. Okay, GPT-3 was a model that I think it is open source even. And what they created was the ChatGPT. So that's a new model in a few versions that exist and for different prices. And that is what we'll talk about. So they created a ChatGPT, which has one more step. And that one more step is called supervised learning and reinforcement learning. That will be abbreviated, but reinforcement learning will use human feedback. So in other words, reinforcement learning from human feedback, which sounds very clear and understandable, but we'll show you why. Deep graph assembly, any thought on deep graph assembly? Let's come to this later when we finish, okay? Because I hear that there were $28 billion invested in generative startups, so there must be a plethora of different competitors there. Meanwhile, that is what they did, RLHF, reinforcement learning. And that is because humans are involved, quite a lot of humans. And the reason that you need humans is because GPT, let's go here, GPT is purely reading all the data from the internet and figuring out what to say next. That means that if somebody gives it the wrong fact, then it will take it as the right fact and it will say the wrong thing next. That is still a problem even with the human corrected input, because how much input you can correct. But before we go and talk about problems, let's talk about the bright side. It turns out that if you have humans in the loop, then on top of more or less precise suggestions, it will also check, is it reasonable? We all know what is bad and what is good. We're almost all philosophers, but it has no such knowledge. So therefore, it doesn't know what's true and what's not true, what sounds plausible and what is not plausible. That's how you can catch it. You can say, when did any crazy thing that never really happened? After 1960, when did Columbus arrive? And it will think that Columbus did arrive after 1960. That's why you need the humans, because it has no morals, and it has, that's a modern way to say. My wife often scolds me for having no morals, so I don't think that's a bad thing. But another thing, no common sense. And common sense is not an easy thing. It's really human experience condensed. And that is why that rhymes with what Noam Chomsky said, because Noam has a very special point of view, and that is a good time to mention it. His point of view is that when the baby is born with internal knowledge of a huge number of languages. You will be surprised. It doesn't start speaking French, but it could. And therefore, then it listens to what is the mother saying. Oh, yeah, I'm an English-speaking country, so I'll start learning English. That's a very special point of view. That's very hard to believe at first. But the proof that Noam brings is that nobody can really learn all that the humans learn. The humans learn to have a feel for grammar in that language, and it couldn't be acquired from learning. Now, that is exactly relevant to our conversation. Couldn't be acquired from learning. So he says there is no way that AI can learn what humans learn, because humans know it from the birth. Okay, according to this point of view, and there is an opposing point of view, but according to this point of view, well, AI has no chance to do what humans do, so we will happily live together ever after. Piaget is the opposing point of view, who says, yes, humans do learn, and according to Piaget, I think if he were alive today, you could have a chance for AI. By the way, Chomsky is 95 years old and very sprightly. Okay, but back, what the creators of ChatGPT use then is the loop, reinforcement learning from human feedback, and they were stopping it from being harmful, untruthful, or biased. And that's a popular thing, because now you go into politics. Anything that is okay 200 years ago is not okay today. So that is something like all the cancel culture, and so all the woke culture, all the taking of the books out of the libraries, because today in the current social climate we find it a bad book, whereas the humanity thought otherwise. Well, if you learn from humanity, you will learn the wrong things, and this is where the current people come and correct all the untrue facts, and there is a whole sea of such things according to the modern view. Okay, so we want to know more. We want to look at GPT's limitations. We want to learn about this improvement, and we want to then look at what's good about this human in the loop and what is limiting about human in the loop. So I'm really thankful for the questions, but I'm leaving them for later. So terminology, a little bit of terminology is that there is such a thing as capability, and there is another thing that's called alignment. So capability is how good the model is compared to the training, or how much error do you make. This error is shown here, right? Loss, it's called loss. And here is a perfect situation where we have 1% loss. In other words, we are comparing the real situation to the model, and we see very little difference. That is good before you start talking about AI and conversation, because you have a certain function you're trying to optimize. That's capability. If you optimize this function, that's called high capability. But alignment is, I'm saying, look, but it doesn't make sense. It's great according to your model, but I'm a human who starts talking to ChatGPT, and I understand that you trained it with very little loss, but the end result is not great. That's the difference between capability alignment, but I want to show you more examples. So capability is optimizing against the function, but who said that the function is right? There lies the trick. Alignment is saying the model really talks the way I'd like model to talk. So that is a practical use that I can get out of the model. And we can right away conclude that ChatGPT is good on capabilities, not good on alignment. They are not the same. So examples, let's say you train a bird classifier, and a bird classifier will do a very limited thing. It will distinguish between sparrows and robins, which I personally cannot do, so it will beat me on that. Now, when they do this, when they distinguish between sparrows and robins, they use a certain function called log loss that measures the difference between not only one specific case, but it on the average measures the difference between probability that the model predicts something and the true observation, which sounds right. But the problem is that it gives you poor accuracy, and that's because they're misaligned. Model like GPT-3 and then ChatGPT, except that we're going to help it. So model is misaligned because it can talk like as if it is normal, but it is really in some instances crazy, and it's authoritatively stating the wrong things. So therefore, the result that it gives you is not consistent with what you would expect for human consumption. And now, if you go back and read any kind of social article about ChatGPT, you will see that humans treat them as other humans. They expect the model to behave reasonably well. And they're very happy when they catch the model is not behaving reasonably well. But there it ends, because they don't know this. They are not technical. They don't know the difference between the optimizing function and the expected behavior. And even if you tell them, they probably won't understand. But you know why is that? Now that you know why is that, you can judge for yourself. So the model might have a low log loss, which is the optimization function that we're creating, but on the real tests, it will have poor accuracy. And that's because they're misaligned. They're capable of predicting anything, and it may not be reasonable. Now, that's the problem. You will get the very well calculated statistical distribution of the results, but it won't be right. It won't make any sense. That's the promise of alignment. It will not listen to you. So we all know how many journalists talk to AI, and they pointed out that sometimes it gets upset and doesn't want to tell you. It talks about reporting you to the superiors, or when you ask it to report to tell you who is your boss, it will say, I'm the boss of the world. These things are reported. It is hallucinations because it's making up facts. It's based on the wrong facts, and you never know why it did this. You never can understand its lack of interpretability. By now, the people say that I complain about your ChatGPT, let's say, and nobody knows how to make it more reasonable. In the end, people limit its creativity. There is a certain parameter in ChatGPT called temperature. Temperature, if it's hot, it's wild. If it's cold, it's more reasonable. But then you take the creative element out of it, and it becomes very dull. Well, these problems you can see when you read the journalist account of how he or she was talking to ChatGPT. In other words, that's not a new thing. Yes, that's a known problem, and that's because it's it needs some help from humans still. Well, let's go on. That's misalignment, but technical misalignment. I see your comments, but not yet. I will talk about them. So the models usually do one of the two things. Either it predicts the next word or it predicts the word in between. When it goes for the next token, it can take the input, the cat sat on the, and then possible answers, pillow, chair, floor, wherever the cat sits. There is no indication of what will be right, but you know what you have in your home and whether you have a cat at all. And if you don't, then you fool the model. But it estimates the probability of the next word, and given more knowledge about you, it might get more, but it's never perfect at that. The masked language model simply gets the word in between. For example, here, the Roman Empire, the word with the reign of Augustus. That's very good, but we don't know if it will predict began or ended. Since you're reading a book, a text on history, you probably know where you are, you probably know what's going on. So you will say began or ended is right. But without that, neither I right now, without remembering about the reign of Augustus. By the way, what's your guess? Should it be began or ended? You see, you're also having problem, right?
I for the beginning of the alphabet, so begin.
You think it's began, the Roman Empire.
Because I is the
Yeah,
capital.
really, I also think Augustus is one of the early emperors, right? And
Yeah,
after that, they were all called Augustus. So
yeah.
maybe it's either began or continued. But for that, we need some knowledge that we just used. Some
The Cleopatra
reasonable.
marriage, the marriage to Mark Antony, Julius Caesar, Cleopatra.
That's because we all know Shakespeare. But what happened before then? Okay, but in any case, without this knowledge, which is really endless, it's a misalignment and it will not get the right thing. So we said that ChatGPT was based on GPT-3, but that it was reinforcement learning from human feedback. So therefore, it was the first reasonable model which was put in production. And you can read rumors about that somehow they were forced to put it in production because, first of all, the quality wasn't there. And secondly, it's because it's tremendous infrastructure. It's a brain talking to all humanity, so potentially 8 billion people talking to it at the same time. What is its size? Pretty much like Google. So pretty big, right? And that's not always working perfectly. Okay, So that's what RLHF. It really technical consists of 3 steps. It's supervised fine-tuning, it's mimic human preferences, and proximal policy optimization. But we need to look at every one of them. So first of all, we are finally tuning the model on a relatively small amount of data to learn the what's reasonable. So we give it a few selected prompts that are real, but that's very limited in what we can do. That is step number 1. Number 2 is mimic human preferences. So the problem is not every review agrees with another review. You can imagine what will happen in politics. Half of the USA will vote one way and half of the USA will vote another way. And the way to test it, was another article where I saw that it refused to praise, to write an ode to Trump, but it happily composed the one in for the current president, Biden, right? So that is a problem. And when you ask humans to correct something, then they disagree themselves. So you need to come up with some reasonable reward model, and in some areas you will still not get it right. Finally, there is the proximal policy optimization, and that's further fine-tuning. Now we see what really is going on there. You can't really repeat this training, at least the way it's done. You can take any model and put it on Hugging Face and give it more data, but you cannot just replicate all the human input, because that's a different humans and a completely different amount of money. So that's why if you look at how you optimize the open AI models, you will see that there is very limited additional training you can do using only the API. And essentially, you are just adding a little bit background information. For example, you can say, how should I call my cat given that my horse is called this way and my lion is called this way? And based on that, it will suggest an answer. So additional training amounts to, you know what, here in the names that I give to my animals, and I have a zoo of 1,000 animals, given that, and you don't have to repeat this after the training, it knows about your zoo. You can ask for the name of the next animal. That's limited. That's what we actually tried last time. We tried to fine-tune the OpenAI model. Okay, now the article that describes exactly how to use human input is right here. The only problem with this article is that they didn't tell us everything. So they didn't confirm the studies, they didn't confirm if they really used it and what were the tweaks. So the article exists, but that's all you have right now. Okay, let's go back to the slides. If you want to read it all with sources, you will download the slides and you will have all the links. But we don't know a few things. We want to know how helpful was it after the training, and we don't have that. We need to know, was it truthful and was it harmless? All of that, the data is missing. So we don't know everything. Therefore, there were quite a few shortcomings of the model as a result, but I'm not negating what it does. It killed $10 billion of Google's worth because it's better than Google. And that is enough. And Microsoft is regarded as a new company with the chat search. So the real practical effect is not the same as the technical understanding. So we need to know all of that. We don't have a study of how that was done. We don't know where the ground truth came. Our human reviewers were very different humans. So we don't know enough about that. And that's the story. So usually I have a lab. I have something for you to do. And I just don't have a lab on that today. So therefore, I want to do this. I will stop sharing. I will allow you to ask questions. And before I will go through your questions that you have asked. If we have the time, then I will give you a very different lab. It will be about quantum computing, and I will briefly show you. That's because I started a new webinar series on Thursdays, quantum computing, and the first question there is, does it really exist? And my first very quick answer is that it costs $2 a second on IBM Cloud. Therefore, it exists. Okay, now I'm reading your questions. Any thought on deep gram assembly, etc.? So no, honestly, I don't know, but let's go. Will tell us what it is about. That I think is advertisement, no? No, it is deep gram and the assembly AI alternatives compared. So says transcribe. It's a transcription tool. 10 times many languages, and assembly AI has 8 languages, and that's not enough for my practical goals. So no, not enough for having an opinion. The next question is interesting, how they left the project name ChatGPT when it was released to the public. Usually, marketing think up of a name that is easy to remember, understand before the software tool is released to the public. A new person using ChatGPT would ask the question, probably to ChatGPT, what is ChatGPT? Right, I totally agree about this, and people ask one of the first questions they ask, what are you? And it prefers to answer, well, I'm just an AI, so what do I know? But as far as marketing, another advice is this: when you are the first, you can use absolutely anything. You don't have to give a thought to marketing. Just because if you're Xerox, then you are the first Xerox, and the people will call every copy machine a Xerox machine after
that makes sense. Yeah.
but
Good point.
ChatGPT obviously came out of the brain of the programmers, because only they use the generative pre-programmed transformer as a possible marketing name.
Yeah, because if you say to me, I'm using ChatGPT to solve that solution, that problem, then that person will ask you, but what is GPT in ChatGPT?
Well, okay, we answered, but you notice that people don't ask this question. They just say ChatGPT, that's it. They think it's whatever it is. But because it's the first, I'm not surprised if the next models will be all called, the ChatGPT, just like Microsoft people, they say you Google, even though you use Bing. You use Bing to Google.
Yeah.
Next question, hallucinations are introduced because of the RLHF. So here my personal opinion is not, no, it's just the opposite. It's because there was no human feedback in the previous model, which was GPT-3. So because there was no check on what it's hallucinating, that's why hallucination was allowed. But it's still not completely resolved, and people are very happy when they pulled the ChatGPT into disclosing how to make an A-bomb and other such stuff, which is not supposed, but somehow you can make it.
Long conversations, very long conversations with ChatGPT allows the hallucination to be induced, I think.
Yes, right, because nothing is perfect, that's why.
Yeah.
Okay, now the next question is, let's see if I can make it bigger. You probably don't see the chat that I'm reading. So want to ask ChatGPT after you become ruler of the world in 223, who should be locked or executed first? I don't know. What did you ask? Okay. Then the next is we discussed what would be the good word. Smaller number of qubits can be simulated on classic computer. You're already going into qubits, so we will look a little bit at that. And we had an interesting turnout the first time we ran. So yes, now makes sense. Come on, George. Okay, that's all I can see here for now. So I'll do that, what I promised. I'll just show you what a real quantum computer looks and what a quantum computer lab looks. So I will, yes.
Sorry, actually, I didn't want to say anything.
Oh, okay.
Yeah, but thank you. This is really interesting for putting this together. This is my first session. I'm finding it a lot, informative and educational.
Thank you so much. I really put a lot of effort into this because I have internet, like all of us, and more than 99% is just telling what other people tell and so on. You need the real stuff. But in any case, I just have these slides here, and I will start briefly the introduction to quantum computing, just so you know what it is about. We won't go too much. I will try also to run a lab. So very briefly, I know your guys are a captive audience. You didn't ask for quantum computing, but I thought it might be interesting. So the first idea is that today there are books for babies. So if you read that book to the baby, then it will grow up saying that, oh, quantum computing, that's what my dad read me when I was 2. And if you want to listen to the book, it will be found here. And I think that if I reshare, what I will do is I will stop sharing. And for some reason, it doesn't show me where I share. Okay, so, and when I reshare the screen, then I will also share the sound from that screen. And what happens then is when I click on the link on the slide, or when I just copy that and go there, and then I will show you the beginning of the book. Somebody reads the book. It's a minute and...
Quantum computing for babies. This is a ball. It can be red or blue. It is 1 bit of information. 8 bits make a byte. Many bytes make data. Data lives in a computer. Computers are useful. They solve problems. Problems are solved by changing data. Some problems are easy and some problems are hard. Some problems are too hard for a computer.
Now notice that it's a very precise book. And what it's saying here is that try to break it into prime factors. That's the hard problem.
Using bits. But wait, what is this down here? It's a quantum bit, a qubit. It can be red or blue or anything at all. Many qubits make quantum data. Quantum data lives in a quantum computer. Data can be copied. Quantum data cannot be copied.
That's a very quick statement of the fact that replication is not allowed in the quantum world.
We can watch a computer at work, but we cannot watch a quantum computer at work.
Well, that's a very quick statement that says that you cannot measure quants or electrons or photons. Otherwise, they will stop behaving like they
We
used
can
to
only
behave.
see the answer it gives. So why do we want a quantum computer? Because quantum computers can solve hard problems. Now you know quantum computing.
Okay, and I'm giving you the link to that here in the chat. Now you will know quantum computing. Okay, so I was going through this slide deck, and today we don't have the luxury of the whole hour, but that was a funny take on it's time to have the talk with your child. Where are the babies coming from? Except that this talk will be about quantum computing. So you can download and look at it, and that gives a set of labs. So as I promised you, a lab, but of course you can Google for a quantum computer and look at what it looks like. Simply look at any picture, and that's what they look like, those quantum computers. So that leads you to think that they probably do exist. The latest and greatest quantum computer made by IBM has 1,433 bits, and there are lots of applications. What it means is that forget the compilers, forget the assembly, go back to the level of individual bits and start building from there. But the reason you would do it is because now all the bits can be in any position, which is 0, 1, but it can be anywhere in between at any time. And as long as you're not looking, they can work together on solving a problem. Now, that problem that you will solve will have to be formulated and solved by a special algorithm, and each such algorithm is a whole discovery. So the first such algorithm that would work on quantum computer and would do prime factors is called Shor's algorithm, and that was the first quantum computer algorithm that worked. So people flocked together to just find out. That's a new big discovery. And finally, the labs are right here. So I'll go there and I will show you one of those labs. Okay. So as we mentioned, and somebody said here that at $2 a second, maybe that's an expensive way to learn. So there are imitations, and you can run the code that imitates what you can do in qubits, but you can only go so far because one qubit has 2 positions, and 2 qubits have 2 times 2 positions, and another qubit gives you 8 positions, and 30 qubits. Well, 30 qubits is 2 to the 10th, it's 1,000, and 30 qubits is million, 1,000 times 1,000, approximately 1,000 times 1,000 times 1,000, so it's 10 to the 9, and after that, it's hard to run the simulator. So you can only go for the 30 qubit computer using the imitation called Qiskit. That's the library name. Maybe I should do this one. But at the current size, 1,433 qubits, it does something that you cannot imitate in Python. However, to decrypt the Bitcoin network is 1,000 times more. So you need about 1 million qubits, but IBM started with 5, and then they went to more than 1,000. So 1 million is somewhere around. That's why you would learn it now. And here I show the lab after it was run. So what you do as a practical exercise, you import the Qiskit library and you build your quantum circuit. And the quantum circuit is composed of gates. Let's say you want to negate the state of this bit. So you're saying X bit. And in other words, you're adding a very, very simple thing. And that simple thing is put a no on my bit. That's all. And it's surprisingly low-level programming. But if you want to solve very big problems, you'll have to build your circuit like this, except that it will be more complex. Here, we're building the circuit 3 qubits, and we're copying them, we're measuring, we're finding out what they really are with the regular bits. And then we can write a simulator. So I'm not going to the real thing, but if you go to IBM Cloud, you'll see that it's just a click of a button that will send you to the real thing. I'm not sure if it's working right now. Only immutations and simulations are allowed. Here I'm explicitly saying use the simulator, then encode my input and do something very simple to it, like the NOT. Okay, I'll give you that lab, and you can look at that lab and around. And if you're interested in that part of knowledge, then just come next Thursday. Okay, so thank you. I'm stopping the share. And again, do we have any questions? It seems like it's too much. Besides, I compressed the knowledge into a very short time. But that's okay. If it provoked you interested, then we will meet again. We'll meet next week, and potentially we'll do an hour on Thursday for quantum computing and an hour on Friday for AI. Okay. Pico GPT session. And what is Pico GPT?
It's actually a smaller version of the ChatGPT with less number of parameters. Or Nano. They're calling it Nano GPT or Pico or Pico GPT. There's one video that I saw done by Andrzej Kaparty.
Yes, that's a great guy.
Yeah, he is like, that session is really amazing. I haven't completed it yet, but he was like actually writing the code. And that gets to the bottom of how GPT predicts, right? The way you mentioned, how it actually looks at the statement that you give, like, I'm eating or I'm sleeping, whatever the next word that comes through. He had done that with simple, smaller parametric values, and he actually built that whole thing. It's like a 1.5 hour session. Amazing tool. I mean,
when Kaparty talks, everybody listens. Yeah, I'll look at it. I don't promise a session on that because, as you see, I'm into the bigger model, and
sure. Okay,
but still very interesting. Very interesting. Question. I've noticed that the coding results require an SR developer to evaluate and do tests. How do you think this will affect the short and long-term software industry? And SR probably stands for software. That's a great question, and some things are immediately obvious. That is the assistant. Yes.
Clarifications. SR stands for senior.
Oh, senior developer. Okay. So first of all, there is a what assistant for programmers. I forget its marketing name, but it's available. It's created by GitHub, and it's available for every platform and MS Code. And I used it in JetBrains, and it works great. And their own statistics is that when they started, programmers kept 30% of the code that the assistant proposed, and now it's 60. And I use it, and I agree that it's very, very helpful. But I think it rhymes with what we were saying. It's not smart. It doesn't really understand. So understanding will be left to the developers. I believe that's a question of forever or for a long time. But that's more philosophical question because we're predicting the future. But practically, yes, it is useful. It's like having a co-pilot, or having a, maybe it is called co-pilot, a co-programmer, pair programming. Would you agree?
Well, if I may expand on it, I don't agree.
No.
And well, no, let me put it this way. I do agree if you're a senior developer. And this is what I'm getting at, is that when it doesn't help, in other words, to give it to a junior developer who doesn't understand that there's a problem. And,
I agree. And
so
fire all junior developers and only hire senior. And how do you go through 0 to senior, right?
Well, my point is that if that's where we go in 15 years, there won't be any more seniors or mid-level developers, because we haven't
because
kept
there are no
pipeline
juniors,
full.
right? If there are no kid goats, there will be no goats.
Yeah,
that's what you're saying. Yes, that is a question that today doesn't have an answer. And just as how do students who use ChatGPT to write the essays, how do you stop them? Okay, that's a good thing.
thank you.
Thank you. Okay, thank you very much. Really, thank you for all. And thank you for speaking up. And I'm just looking at the questions. And John was asking, how do you objectively test if it understands? You just try. You talk to it. And everybody, thank you and have a great weekend.
Thank you.
Thank you.
You too.
Thank you.
Bye.
Bye-bye.
Goodbye.